Thank you. Grüezi miteinander. Welcome, bienvenue. My name is Katja Jenny. I'm the head of project of the Pop-Up House of Switzerland in Stuttgart. And I would like to welcome, first of all, our live audience who could make it here to Stuttgart and be able to join us in person, live from the house. But also today we already have the first record. For those of us who are with us for the first time, we've opened 6 days ago, and today is, as I said, the record for the largest online community. So welcome to our participants online. We have opened a chat function for you guys, so feel free to post your comments, remarks, and any suggestions that we will then consider during the panel. As you might know, the Pop-Up House of Switzerland is a project from the Federal Department of Foreign Affairs. We are concerned with nation branding and the perception of Switzerland abroad. And during the pandemic situation, we have realized that one of our most important partners is very close to us. It is Baden-Württemberg, a neighbor of Switzerland. And Switzerland has the largest trade volume with Baden-Württemberg. Within the European Union, it is Baden-Württemberg that we have the strongest connections with. We share a common living room and a culture, and that is why we are here now for 4 months to strengthen this connection and to foster our relationships. We have a very interesting program for the next 4 months. You can check it out online on so-schweiz.de. And I am very honored to announce today's panels. That is one of our events that we have now for the 4 months. And today with us is the ETH Zurich. And I have the pleasure to welcome with me on stage Dr. Chris Lübken. So now I need my sheet.
Hi.
Chris, hi Chris.
Hi, Katja.
Chris is the leader of the Strategic Foresight Hub in the Office of the President at ETH Zurich. His outstanding and interdisciplinary career brought him to the 7 corners of the globe. The University of Oregon, the MIT, the Chinese University of Hong Kong, or the Global Engineering Consultancy Arup in London are just a few of his remarkable milestones. He is deeply passionate about curating constructive dialogue, discovering opportunities which will be created by change, perhaps, and most importantly, to evolve positive solutions to the profound challenges we face today and will be facing tomorrow. Chris, very happy to have you here. The floor is yours.
Thank you so much, Katja. Thank you for joining us all here online and here in the House of Switzerland in Stuttgart. It is truly a pleasure to be here, and I can't wait to have the dialogue we're going to be having today. As I said, my name is Chris Lübken, and we are coming to you live from the Pop-Up in Stuttgart, and thank you for joining us. Today, our fascinating dialogue is entitled The Future of Food and the Food of the Future. Now, I'm sure all of you are as curious as I am as just what that looks like, what it tastes like, and what it will bring. Now, we were scheduled to have 2 amazing scientists with us today. Unfortunately, one had to run home or fly home. You can't run from Stuttgart to Barcelona, but you could. It would take a little too long because her mother fell ill, and unfortunately, Gisela had to go back to Barcelona. So we do have Iris Haberkorn with us, and our time together is going to be about 60 minutes. The first 25 is going to be Iris making a presentation, talking about, not quite yet, making a presentation, and then she and I are going to have a little bit of a dialogue, and at any time, very shortly thereafter, you will be able to ask some questions of us. And mostly of Iris, not of me. And all of you online, you will be able to ask questions as well, so please pop them into the chat, and we look forward to answering as many of those as we can. And so, now, without any further ado, let us see who Iris is. Iris is a food scientist with Swabian roots, who started her career at the University of Hohenheim. Her passion for food science brought her to the ETH Zurich in Switzerland, where she completed a PhD in the Laboratory of Sustainable Food Processing, and where she currently is doing a postdoc. We're very, 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 very glad to have her. She is fascinated about questions relating to our contemporary food system, not just the elements, but the entire system, and how we can sustainably transform the role of single-cell proteins, including that of microalgae, and what the future systems could look like. Now, I've seen a little bit of this already, and it is really fascinating. So I really ask you, and she's ready for easy and hard questions. So this is a prompt for those of you who are here and online to put on your thinking caps, and let's ask some kind of cool questions about where the future of food and the food of future will be. So, without any further ado, Iris, the stage is yours. Let's give her a welcome. There we go.
So welcome everyone. Also warm welcome from my side. I'm super excited presenting in front of a live audience again, which hasn't been the case for like 1 year now. It's really nice seeing those faces here, and of course also having the online audience watching via the internet. And I'm really excited presenting you the research that we are conducting at the ETH Laboratory of Sustainable Food Processing, and also give you probably a glimpse on what Gisela Detre, who unfortunately couldn't be here or can't be here today, is doing in her research, a bit of an idea because of the collaboration that we had with them. And
oops, my bad.
Unfortunately, I won't presenting about cheese and not about chocolate, but I hope I can also give you an insight of what ETH is doing here in the food business and how we might, or what we might be eating in 30 years. And therefore, I would like to start with the following. Imagine the two situations. Situation number one, you and 9.7 billion other people are living on this planet. This means a population increase of around 30% from now, an increase from 7.6 billion people to 9.7 billion people, impacted by an increasing urbanization. So more and more people living in cities and more people living on this planet. Situation number two. The guy behind me in the fancy suit wants to encounter a long-term mission to outer space, exploring Moon or Mars. Which challenge do both situations have in common? Exactly, it's sustained food supply. However, with the systems that we currently have here on Earth, we are challenged to sustain a growing world population. Our current agri-food systems are causing soil depletion, water scarcities, and high levels of greenhouse gas emissions. Our current agri-food systems are the major drivers of anthropogenic climate change. And what that was nicely shown by the current Lancet report, or by the last Lancet report, where they show the environmental effects of our food systems or various earth systems on parameters like greenhouse gases, freshwater use, phosphorus, and nitrogen cycles. And it clearly shows that if we continue our business as usual, we won't be able to sustain a growing world population in a sustainable manner, because we will have more and more greenhouse gas emissions, more and more phosphorus or nitrogen that is going out and that is affecting our crop systems, our agri-food systems, to transgress our planetary boundaries. So we need systems that are more sustainable in order to sustain a growing world population. And here the United Nations have set the framework of the Sustainable Development Goals, where they aim for transforming our current systems into a more sustainable solution where food systems are at the heart of at least 12 of the 17 Sustainable Development Goals. And here, plant-based alternatives like microalgae, but also pulses, have emerged as a quite interesting alternative, owing the sustainable notion of their connected value chains. And here you see different protein sources and with their time scales to market. And here we are talking in the short term as an alternative for protein sources, for plant-based protein sources, about pulses, But also here you can see algae, microalgae, macro and microalgae. But we are also talking about insects and other single cell-based technologies, such as cultured meat, for instance. But what are we actually talking about if we are talking about microalgae in single-cell organisms? I mean, it's hard to imagine. Probably all of you know sushi and the algae that are wrapped around the sushi. However, these are like huge algae, and we call them macroalgae. But what we are investigating is way, way smaller. So we are talking about a microscopic range here. And you can see the adenovirus or E. coli or red blood cells in comparison to a human here. And what you can see is that the microalgae locate in the range of red blood cells, and depending on the species, we are talking of a size between 10 micrometer and 100 micrometers, so they're fairly small and you can only see them under the microscope. This also makes them very attractive if we think about future food processing. Microalgae have a couple of benefits, one of which is, for instance, the CO2 uptake. So if we grow them, like you see them here, they can capture CO2 and create high nutritional biomass. They have high quantities of protein, between 60 and 70%, depending on the species that you employ. And what is really interesting is, with the microalgae and also other single-cell solutions, we are actually independent of arable land. So we don't use, or we don't need to use, any cropland for cultivating the microalgae. And this makes them really attractive because we can, for instance, cultivate them in cities. And here you see a comparison of the land requirements that we need for different protein sources. And you can see that here on the top you see beef, or like the traditional sources of protein that they currently have, so meat-based, beef, pig, poultry, and in comparison the microalgae, where we only need 1.6 square meters per kilogram protein. Therefore, microalgae are really attractive, and we can, for instance, also cultivate them in cities. And here you can see two examples of how future food processing or food production could look like. For instance, here in Hamburg, they already established the so-called Algae House, where they're cultivating algae in the facade of the house. So it's really urban food processing next to you, food production next to you. And another example is the startup Analogues, where they are cultivating microalgae on the rooftop in Bangkok, in those buckets. Of course, this is not really industrial scale, and we need to still improve those solutions. However, it's a first step to urban food production. And of course, then we can also consider further steps like urban food processing. If we go to the houses, if we go to people, that you just cultivate the microalgae in the cities and probably also process them in the near future. And we are not using any arable land for that. If we now look at current microalgae production systems, if we want to go on an industrial scale, they still look different. What you can see here on the very left are so-called open pond systems, where they're cultivating the microalgae. However, of course, these are really prone to contamination. If we want to go, for instance, for pharmaceutical grade or nutritional supplement production, we would want to go into the systems that you can see here in the middle. But of course, here again, we are independent of arable land. For instance, those ponds that you can see here, you can establish them somewhere in the desert, close to the sea, that you can, for instance, also use sea salt or sea water for cultivating the microalgae. However, if we think about the price of microalgae production, which is currently a major gap to really have economically viable microalgae production, we see huge differences between the different systems. And what I showed you so far was the so-called phototrophic microalgae production. And you can see here the open pond systems on the very left, where we are at like 3.4 euros per kilogram in producing the microalgae. However, if we want to increase process control for having more pure cultures, there's a huge increase in the price of microalgae to 19.6 euro per kilogram. The advantage here is With this phototrophic microalgae production, you can see the microalgae are green, so they are conducting photosynthesis, which means that we can capture CO2 for producing the biomass and energy derived from light. On the other hand, you have another cultivation system which on industrial scale, or is more employed now, which you call heterotrophic microalgae production. And these are cultivated in so-called fermenters, where you have the lowest production costs of 1.7 euros per kilogram. Here we are using organic carbon for cultivating the microalgae, which means that we, for instance, can use sugars, but another option for making this microalgae cultivation more sustainable would be, for instance, to use food industry side streams or other side streams which are rich in carbon, nitrogen, or phosphorus to further lower the production costs, but also make microalgae production a bit more sustainable than it is now, and creating so-called circular economy approaches where we are using all the components that we are producing for creating something with high nutritional value. However, what you can see is if we really want to be competitive with microalgae biomass, we further need to decrease the price, because, I mean, here for the fermenter we are at 1.7 euros per kilogram, but if you look at the biofuel production, we should achieve prices of well below 50 cents per kilogram. And this is currently where a lot of research is conducted to really decrease the production costs of microalgae. And what is also important to mention here is because algae are very often considered a sustainable solution of the future. However, current microalgae production systems are not more sustainable yet than, for instance, soy protein or pea protein. Just looking at the economies of scale and also the technology readiness level that we currently have available for the microalgae. If we now think about food application, there's also another difference between the phototrophic and the heterotrophic microalgae production, which you can see here. If you consider the phototrophic microalgae production, owing the photosynthesis that we are conducting, we are producing pigments, mainly chlorophyll, which produces this green biomass. However, this is a major concern, or not concern, but drawback if we want to produce food, because a lot of people don't want to have the green food. It doesn't seem appealing to them. Also, if you process it, it turns rather grayish. So you have the opportunity of capturing CO2 here and using light as energy, but you're producing green biomass, which the consumer doesn't want or is not that prone to consuming somehow. And if we go to the fermenter, where we can use organic carbon, so side streams or glucose, we are producing this really nice golden or yellow biomass, which turns out quite nice if we want to like include it into a food product. And to see what you can make out of this algae, we have a small video for you about the research that we've been conducting in our laboratory, from the cultivation of the microalgae to the final processing, and what are also the major barriers currently, and how we want to tackle them with some technological approaches. In 2050, there are gonna be 9.7 billion people living on this planet. Food production will need to increase by 70% to meet the demand of a growing world population.
However, the majority of our arable land is already occupied with existing crops. So what can we do? To feed more people, we believe we can go for single-cell technologies such as microalgae production concepts, where we don't need to have any arable land. A microalgae cultivation may not look like food at first, but microalgae biomass contains up to 70% protein. and they are full of important nutrients and essential amino acids. They can grow on infertile land or even in buckets on rooftops, as already happening in Bangkok. Currently, free meat cannot be delivered by cultivating it. Plant and algae sources present another option for alternative protein sources, which are much more easier accessible. And best of all, microalgae pose a potentially sustainable solution in a world where soil depletion caused by global warming and overfarming is becoming an existential issue. So why aren't we seeing microalgae products on the market? Well, there are two challenges. Firstly, there are a bunch of inefficiencies making microalgae products, which leads to high production costs and limited affordability. Secondly, because of this production cost, there are limited attractive products for the consumer on the market. So let's improve production.
And that's where we come in. You might have seen blue, green spirulina in your local chemists. It's been harvested for generations. As well as being beautifully colorful, it also packs more protein per pound than meat, soybeans, peanuts, and other typical vegan options. So to maximize this protein powerhouse, we grow it in tanks and use a process called pulsed electric fields, where we stimulate and nudge it with continuous pulses of electricity to harvest the protein. The challenge here is testing how much to stimulate the microalgae so we can get the most out of it without killing it. We found that we could boost production of microalgae biomass with valuable proteins by up to 17% thanks to very specific electric pulses. Moreover, we could even mix a yellow kind of microalgae into an alternative meat, creating something more nutritious.
The world desperately needs new sustainable food sources. With more research like this, microalgae could soon be at the top of your shopping list.
I think we're almost done. There you go.
Yep. So yeah, as you can see, microalgae are a potentially sustainable solution for our future food systems. However, more research needs to be done in this area to really make them more sustainable, but also economically viable. And another area where microalgae arose as a really interesting opportunity is the collaboration, or is the research that Dr. Gisela Detrel is conducting in her laboratory. Because if you consider doing outer space missions, flying to Moon on Mars, you don't want to be reliant on the resupply of mass. Shooting 1 kilo of mass to Moon costs around 30,000 euros. So it's quite expensive, and also if you want to travel to further destinations, it won't be possible to really resupply mass. So we need some sustainable solutions here, relying on circular economy approaches that sustain the astronauts during long-term missions. And circular economy in this case means that we are using everything that we are producing to reuse it again. And here in the case of microalgae, they've been designing a microgravity adapted photobioreactor which enables them to cultivate microalgae under microgravity conditions. And currently, mainly physicochemical components are used for that, so the Sabatier processor and the electrolyzer, especially for atmospheric control. However, these are not closed circles. So there's always, you can see it here in the bottom, for instance, methane leaving the process. However, we want to have a closed process. And here, microalgae are a really attractive biotechnological solution because they can use the CO2, capture it, and transform it into oxygen, but also highly nutritional biomass. And here, our group is involved in the food processing or the upcycling of the microalgae to really create something of nutritional value and edible, stable and safe from a microbiological point of view for the astronauts. And here With this circular economy, we can learn a lot also for our terrestrial systems, because in the future, if we want to create a sustainable agri-food system, we need to reuse and not waste to create something high value, edible. And here, during today's presentation, we saw that cellular agriculture, so single cell-based value chains made by microalgae, but also yeast, bacteria, or also cultured meat, a viable option. However, also insects and other processes need to be taken into consideration, of course. We need a sustainable intensification of our current crop systems, coupled with technological innovation to create circular economy approaches if we want to sustain a growing world population. And with that, I would like to thank you, and I'm looking forward for an interesting discussion on rethinking living and how our future food systems might look like.
Iris, thank you so much. Let's give her a hand. Thank you. And we're just going to go ahead and if you could go back one slide, please. If you go backwards one slide. 2 slides. Yeah, there we go. 3 slides. There we go. I want to hit with the astronaut slide with, okay, again, one more. Oh, come on, guys. Okay,
Yes.
we're fighting. Well, I like the circular economy one with the microalgae in the middle. There you go. So what's interesting to me is how you said right at the very, very beginning that we basically have one food supply, the same food supply between the astronauts and us. Can you elaborate on that? Because I think the astronauts are in a spaceship and we're on Earth. So why is it the same?
So I don't want to say it's exactly the same, but I mean, currently growing trees or crops in space, NASA is doing a lot of research on bringing tomatoes or lettuce onto the ISS. But it's just the systems and the thinking that we can learn a lot from that space research, especially those circular economy concepts, because if you're on the ISS or in outer space, there is no other option but using the stuff that is given to you, recycling it, and making something of high value out of it again. And I think this is a learning that we can also use here on Earth for creating our terrestrial systems that we have. So for instance, if you look at food industry side streams, not dumping those side streams, but using them, for instance, for cultivating microalgae.
Yeah, I think that's a really good point. Let's go ahead and have a seat now. I think you did a great job. Now we can just rest for a second. There we go. I'm going to put those here. Because Buckminster Fuller always said, talked about Spaceship Earth. Mm-hmm. This is the American architect, planner, designer, whatever, kind of entrepreneur. And that's what I was thinking, this is where we have a spaceship. We only have one little blue planet. And so there's lots of similarities in that they're both closed systems, right? And this is when you had another diagram which is showing with the business as usual, the impact, the various aspects of the food system, which were the phosphorus and the nitrogen, I think it was an incredible impact when we're looking out to 2050 if we continue. Yep. So can you explain really quickly what we use phosphorus and nitrogen, what are those used for, and why are those having such a huge impact?
So it's mainly, from the crops that we are producing and the fertilizer that we are using, and also if we want to increase meat production, if we want to feed a growing population with more and more meat, or animal-derived meat, there will be nitrogen in the cycle. So and if we continue our business as usual, this will be increasing and going into our landscapes.
And so with your algae production, you're saying you don't use phosphorus. I'm trying to think of what's the big difference there, because that's a huge impact, and there seems to be no impact with algae. So you don't use phosphorus at all as a fertilizer.
We are using it, but we are using it for creating biomass. So it's not given out or on the planet. So and what you could actually also do is couple this microalgae production, for instance, to crop production, and use this nitrogen. It's also done a lot, but then the microalgae are not applied for food applications.
Got it.
That you capture the nitrogen or phosphorus that is out, also heavy metals, for cleaning the water for wastewater treatment.
Mhm.
But then, of course, it's difficult using them. If you use manure and cultivate your microalgae on manure, you don't necessarily want to use it for food application. But then, yeah, I mean, you can also produce other things out of microalgae.
So I have to ask you, for me, the obvious question is, does this stuff taste good? I mean, it's green, okay. I mean,
So-
Dr. Seuss had this book, the Green Eggs and Ham. And this is sort of a well-known children's book but does it taste terrible? I mean,
I need to say it's a really good question, and you saw those meat analogues that we are producing, right? From the extruder, it looks like, yeah, plant-based meat. We haven't tried it. But, I mean, there are other microalgae products on the market, and what people usually say is that it tastes quite fishy. Because, I mean, they're also derived from the sea. You have all those fatty acids that make the taste. So, yeah, they taste a bit fishy, but, I mean, you probably one can cover up for that.
no, it was interesting.
More research, yeah.
So it sounds like, are we at the beginning of this exploration of microalgae, or has this been going on for 20, 30, 100 years? Where are we in the development of this research?
This heavily depends on which aspect of the research that you're looking at. Because
Okay.
algae in Asia, they are consumed for ages.
Right, yeah.
So it's not a new thing. The new thing is using them as substitute for meat products.
Yeah.
For instance, in here, I think, so for the cultivation part is also going on already for ages. If you look at universities like Wageningen, they've been doing it for 10, 15, 20 years, and also in Asia, it's going on for longer.
Yeah.
But if you consider the food production, this is a really recent hot topic that currently more and more startups are also emerging on the market, trying to use the microalgae. So I would say, I mean, it comes with the whole meat replacement.
So there's a vector of trying to,
Yeah.
and just new protein. So on the one hand, it is a traditional food in some parts of the world, and it's a new food in other parts. And this is the exciting thing, right?
Yeah.
And so when we think, I'll get off the taste in just a second because if I think of it at the beginning of the research, with food science, we're going to be able to alter the taste with time. And so the key at the moment is getting the production of these proteins, of the production of the algae moved up. And then the taste we can sort out in due course. Or do you think we're just going to have fishy food for the rest of our lives?
Get used to it. It will be fishy food forever.
Oh, no.
Also for the astronauts. No, of course. I mean, there will be solutions. And as I said, there's more research going on to really make attractive products. Not only like, so there's one startup in Singapore that they're really, it's called Sophie's Bionutrients, that they have like the first algae burger that they're trying to market and do. And so there's stuff going on, but of course, yeah.
Okay, so let's come to the production, because you did talk about the production with the figures about the cost per kilo a bit, and different types of production, and how this could be in a desert. We could do this in a desert and land which we've destroyed in many ways, potentially, which is really fascinating. So are there certain parts of the world who are already really interested in this, or is this something which you're, like, and the team are trying to kind of push onto the world?
Well, I mean, there are different aspects. So the first thing is, of course, I mean, there's already, for instance, in Dubai, I know, or in Portugal, in Spain, also in Africa, in Israel, in the desert, they're really huge in cultivating microalgae.
Yep.
Here you need to, of course, also consider how you want to cultivate them, because, I mean, if you need to bring fresh water there, or like carry all the sea salt from the sea to the microalgae, you also need to ask a question about sustainability, and yeah, so it's also questionable. There's one approach in the Canary Islands that they are trying to cultivate the microalgae on the sea already. So you have all the heating, cooling system. You already have the seawater, so you can produce your food there. But of course, this is out of the cities. And before, we've been discussing about urban food production.
Yeah.
So, and we've also discussed it before. For instance, Singapore is really interested and keen on producing food, urban food production with a 30 by 30 initiative, where they're trying to ramp up their domestic food production from 10 to 30%. And there, they're like really keen on doing vertical farming, but also producing microalgae.
So could you imagine this becoming like a really hyper-local protein source? Instead of shipping this protein around the world, you could quite literally do it in your backyard or on your rooftop. Is this part of what you're hoping to see?
Yeah, partly. So we are kind of dreaming of, I mean, you saw this house, this algae house in Hamburg, which was at that time quite visionary. Someone going there, like growing microalgae somewhere in Hamburg where you don't have optimal heating, not the optimal light. But of course, urban food production, right, at your place, I mean, having like a reactor, for instance, in the ground, or I mean, for the heterotrophic microalgae production, you don't need light. You could grow them at home, and then you could also have local food production. If you think about 3D printing or other solutions, that you have your algae reactor at home, or like just for one apartment block, one microalgae cultivation tank, and then also immediate food production there with the systems that one can establish, like 3D printing, whatever.
So maybe we need to be telling the building authorities in different parts of the world that they need to be setting aside a room in the basement for the algae fermenter.
On the one hand, yeah, it would be nice. So let's try to do that. But on the other hand, I mean, also if you go to Zurich, there are all those underground farming initiatives going on. It's not only microalgae, but they're trying to do this urban vertical farming using unused space to really grow food there. And this might also be an option. You don't need to build like new buildings or other things, but just use unused space for cultivating not only microalgae, but also other single cell protein. And this is the beauty of having them. You can just locate your reactor wherever you want.
And how big are these reactors? If I'm like a family of 5, 6, or whatever with your extended family, how big of a reactor would I need in order to get the protein which my body requires, not necessarily all I consume? Those are two different things, right? You know.
Yeah, true.
Yeah.
I mean, there you also need to consider that you probably don't want to cover up your whole protein supply from only microalgae, because you want to have a diverse diet. And the group of Gisela Detrel, they estimated that around 30% of your daily protein intake, or of astronauts' daily protein intake, could be covered by microalgae.
Really? So about 30%?
Yeah.
Interesting.
Yeah.
So how big does the reactor need to be? And I'm just trying to get an idea. Are we talking like the size of this table, or this glass, or this room?
The room is probably too big for a 4-people household, but the glass might be not enough. So we are probably talking about 100 liters if I need to. I can't give you like exact numbers.
No, I'm just curious, because it's a Größenordnung, you know, it's like the size of the stage or something, because the reactors were there. So we did offer the people here and the audience here physically and also online could ask some questions. And I'm looking at you. I'm going to ask Iris one more question. I'm going to look at you. Does anyone have a question yet they'd like to ask? Looking in the room. Not yet. Then I'm going to, oh, come on. All right. There's a couple questions here. I'm going to ask her one more question. I'm going to ask Iris one more question. I'm going to come to you both. And the rest of you, I expect you all to have a question, okay? There's no free lunch here, not even algae fish tasting lunch, all right? So when you think of the future, because you're trying to recreate a new normal, right? Your dream, in many ways, is to help us replace animal protein with microalgae protein. Right. So at what point do you believe in your heart of hearts that this is, are we 5 years away from this? Or like fusion, it's always 20 years away? Are we 3 years, 2 years? I mean, when do you think we can really start to see this in the supermarkets or in our neighborhood stores?
I mean, what you realize now is, I mean, we are like right at the tipping point, you know, more and more people
Okay.
considering that we need to shift to a plant-based diet. But of course, I mean, we can't like guess from Zurich to other locations in the world, but what we see now, there's a huge trend in shifting to this plant-based diet, a lot of research going on. There are already some microalgae products, for instance, in Singapore in the market. If we talk about single cell-based cultures, in Singapore you already have the first cultured meat. So it's chicken wings, I think, that you can already buy there, and it's from cultured meat. So it's not that far away.
Okay. So that's really interesting too. You heard it here today that, you know, it's not that far away, that we're going to all have this soon. So I think and that's exciting to hear because it's always seemed like so far science fiction-y, which is kind of cool that it's getting there. So we have a couple questions here. I'm gonna ask you first online, and then we're gonna come over here, because you can give the microphone afterwards. So, yeah, how many do you have? You have like 15 questions? You got one or two? Okay, let's give us one.
So,
Yep, go ahead.
is it on? Yeah. Okay, so we have one user who wants to know more about the possibilities to feed also animals with the microalgae.
Yeah, it's a really good point. It's currently also used for feeding animals, as far as I know. So what they, for instance, realized from cows is, I mean, the WEF, they also showed it, that if you, I just saw recently a video clip from them, if you feed cows with microalgae, you decrease the methane production significantly. So feeding animals with microalgae is already done. However, I mean, we want to develop a sustainable solution for humans, so we should also be working on that part. But of course, I mean, for instance, if we talk about the insects now, they are mainly used for animal feed, because if you consider fish feed, fish are fed with other fish, as far as I know, which is not a very sustainable solution. So here also, insects mainly used in animal feed so far.
Yeah, so it's an interesting question. It's like the direct versus indirect, right? And you're kind of looking at the direct opportunity for us to have the protein versus the indirect. So which is less efficient. Let's get the microphone over here to this gentleman right here. We have a question here.
Yes, thank you very much. Well, you just asked your last question was the one I wanted to ask, typically, right?
Well, you got to come up with a new one now,
Exactly.
right? So you got the
I have to
microphone.
improvise.
Yeah.
No, maybe what could authorities to boost this new approach, to make regulation that maybe could help this new approach to be more available?
So what can who do? I didn't hear
The official authorities, countries,
okay.
what could be a political approach that maybe could
help.
help this approach?
Yeah, that's a really, really interesting question. So, I mean, if we consider the microalgae now, I mean, the question is whether it's really governmental regulations that are hindering us currently to really implementing the microalgae, or whether it is like the economic viability. So you can then always say that we probably push with, I don't know, with funding or with, but yeah, so the main gap with the microalgae currently is not the governmental regulations, as far as I know, also not like the products, it's really the processing and the costs that we have with the processing. And if you want to substitute meat, then we need to decrease the production costs. But still, I mean, if we want to really have a shift towards a more plant-based diet, I mean, this is a really general question, how can we shift diets in general to a more plant-based diet?
So, but you did mention, I think when we were walking towards lunch, that some countries have just now, in the past, say, 5 years, now allowed algae to be sold, because there has to be permission to sell this, because this is food, so citizens need to be, it has to be approved, right?
So Yeah, I mean, for the micro, this is mainly for the insects. I mean, insects are approved since 2017 in Switzerland, and in the EU, it's since this year. And for the microalgae, what we have is that for food production, we have currently 7 strains that are allowed for food production because, I mean, it's novel food, and they need to like undergo heavy testing and regulations so that we really have new species on the market. So, and some companies, startups, trying to speed up that process of having more microalgae approved that are probably more efficient in production.
Okay, so I mean, so there is a side of this, this kind of, erlaubnis, in Germany, cool. Okay, we have another question right here.
So my question is actually related to the previous one. What about subsidies? I mean, we know that meat production is heavily subsidized, fishing is super heavily subsidized. Does it need to make a shift really from, apart from the research, of course, but if you really want to get her to, ranges like 30% you mentioned, I guess we need subsidies somehow. Or shift subsidies from meat production and fishing to this kind of food production.
Yeah, also probably. I mean, there are a couple of startups. So this is what I meant with the funding or subsidies. I mean, there are a couple of startups also in Switzerland now trying to ramp up and to produce microalgae, but it's really difficult for them because, as you can imagine, if you want to produce microalgae, there are like those bunch of inefficiencies that you need to cover up for, and you have very high initial costs if you want to like ramp up such a startup, the researchers, the photobioreactors. So subsidies might be an option there, but of course also making people more aware of this like novel kind of food and that it's available. I mean, we're discussing about that phototrophic microalgae are not very well accepted because they're green. So and probably we need some like marketing campaigns also there. So.
Spinach is green.
Yeah.
Broccoli is green. Brussels sprouts are green.
Yes.
So
Yeah, so it's on the one hand, I mean, it's the biomass, and there are studies also from the consumer science group at ETH that they were investigating it, clearly showing that people don't want this like green color, but I also think like, I mean, spinach is green, broccoli is green, it's just like connected with being healthy. But of course, then you also need to consider, I mean, it's like this one thing, then, I mean, there are different aspects. So this is the first. The second one, if you process, it turns grayish. Yeah. So you can use the green powder, which might taste tasty, and this is like, not tasty, but fishy. And like the third point is you have the chlorophyll in there, so if you eat the raw microalgae, it might taste like grass with all the chlorophyll and a bit of fishy taste. So it's not only the green color.
So you're really selling this, let me tell you, gray, fishy grass.
No, just because we say, I mean, it's not only like this, it looks green and people don't like it because it looks so healthy. Yeah. There are also other aspects to it, but of course also with other, I mean, there's nothing that might be a drawback there.
No, I think, I mean, I'm making a little bit of fun of it, but I think it's actually a really, really important point, and taste change, I think this is when, I think also with humans, we change our tastes with time as well, and we become accustomed to things, and there's that evolution of taste which is based on necessity. That could also, necessity is the mother of invention, right? So
yeah, true, but if you like consider Western diets, people being used to, like they get everything they want, they can eat everything they want, and then telling them, you need to eat the microalgae now because they're more sustainable or they're more healthy or it's necessary, so yeah.
Okay, we can disagree on this one, but I really think this becomes an aspirational change, right? And this comes back to your question about legislation versus aspiration. And if we're thinking about the next few generations, 4, 5, 6 generations, we know we have to make some changes. And this is one which we'll need to make. This is just a given. And so therefore, at some point there will be that transition. I think that's kind of it. And what's inspiring to me is just to see how far you're coming already and to where it's going to go. So I think there's There's another couple questions right here. Yep.
I'd like to earn my algae-covered chocolate here. So thank you very much, first of all, for your very interesting and insightful talk about the amazing research that you do, also in collaboration with your partners here at the University of Stuttgart. That's quite interesting how you get those two things together on Earth and the interplanetary aspect of it. I was wondering if you, in your research, also have covered topics like let's say more ethical aspects or aspects of acceptance, as you mentioned. So not only considering taste, but also maybe acceptance on a public level, ethical dimensions of processed foods, and what it might lead to in the next part of the chain, let's say. Do you have reflection forums or ethical forums of exchange where you talk about these topics among your scientific community? Where does this exchange happen? Do you have outreach activities where you go into the public like today and explain it, or try to sell, or how does this happen within the scientific community? I was wondering.
Well, on the one hand, so in Switzerland, there's like a quite strong community with startups, the Impact Hub, and that they're pushing. Or we are also doing a lot of outreach, like doing this video to bring this closer, this topic closer to people, or going here today. And on the consumer research side, so there is a consumer research group, for instance, in Zurich, that they've really doing a lot of research on those alternative protein sources. And it's not only microalgae, but also insects and the acceptance of them or among consumers. And they clearly show that the acceptance is not yet there. I think the hurdle for microalgae might be a bit lower than for insects, because if you talk about insects and with people about insects, they're like, no, we don't want to eat it. So there's still a bigger hurdle there. But we are planning to do more research there, so to really take into account also, what is the consumer expecting from those products? Do we really need to produce a meat analog from microalgae, or can we just create something completely new with microalgae? Why are we trying to substitute something with something that will never really taste like meat? So so there will more research be going on there to really think about what does the consumer want, what are the expectations with products for the consumer, and then also doing more consumer studies on the products that you saw here now in the video. How are consumers accepting them, and in which kind of products will they accept the microalgae? Can you deliver tacos or kebab with some algae in there, or is it more bread? Or do consumers really want the whole microalgae, or do they only want to have special components out of microalgae with added nutritional value? So there's a bit of research done on the consumer part already, showing that it's not that well accepted yet, and more is then, so I know there will come more, and of course there will also be dissemination and outreach and really going to people and communicating this, because it doesn't make sense staying in the lab and having our findings and not communicating them.
That's really great, thank you. It makes me think of the innovation curve is always the first thing of any new thing you imitate. The easiest thing to imitate, and then it takes a while to evolve into the appropriate application. And so it's we're at the very beginning of this curve at the moment, right? When it's which is really. So I think, was there another question online? And then we're almost close to time. So pop the question, and we're gonna.
Okay, thank you. Yes, actually 2 questions from our online audience regarding the protein of the quality of microalgae protein. Does it compare with plant proteins or proteins in the meat production?
So it's a really interesting question, because protein is not only about quantity, but also about quality. And of course, this has also been evaluated. You need your protein source to deliver the amino acids that your body requires for building up muscle and protein, especially the essential amino acids. And from what I know is that microalgae are very close or even above the recommendation of the WHO in their protein composition, even having the essential amino acids in there. So
That's interesting. I didn't know that. I've learned something about the quality of the protein. And can you, with your microalgae, create different typologies of protein? So you have like super high quality protein and mediocre and low. So it's like dark green, light green, and heavy green or something. Or is that?
So, I mean, there are different microalgae with different protein contents. Some only have like 30, some 40, and some even 70%. And then also depending on the microalgae species, it might be that there's slight differences in the amino acid composition.
Interesting. Interesting. So we can have amino acid cocktails in the future. Instead of a gin and tonic, we have an amino tonic or something.
With a 3D printer.
The algae tonic, yeah.
Just printed what your body exactly needs.
Yeah. Yeah. This is, instead of personalized medicine, we're going to have personalized algae.
Yeah.
Is that all right? Yeah. I'm not sure if I should say I can't wait or not. This is sort of like that.
And they're fishy tasty, so.
No, they won't be fishy tasting. Come on, they're gonna be algae tasting.
Just joking.
Yeah. So we're unfortunately very close to the end of our time, and truly, Iris, it's been a delight speaking with you, and the questions were answered with great aplomb and accuracy and clarity. So thank you so much for sharing your knowledge and passion with us. Thank you.
So thank you, Chris, and thanks everyone for listening.
It's really great. Now, as we said right at the very beginning, we were to be having a native Stuttgarter, Gisela Detrell, who was going to be with us, and I told you at the very beginning she couldn't be here because of the illness in her family. Now, she, when talking with her and prepping for today, she really said that after living here so many years in Stuttgart, and this is a quote, this is now her home. So for you in Stuttgart, congratulations. And how you did that from someone from Barcelona, I don't know. Well done you. But as she said, her thoughts very often are quite far away on Mars. She's an aerospace engineer, a PhD in life support systems. We heard a little bit about the work from Iris, but it's really quite fascinating to see her work here at the University of Stuttgart with her goal is to ensure astronaut survival in space. We can't get to Mars if the astronauts don't survive. That doesn't quite work so well, And to enable long-distance human space flight. And who knows, maybe someday she'll be producing food on Mars herself one day. Just to say, Gisela, when you see this, we do miss you, and we wish you all the best and your mother a speedy recovery. So with that, I just want also to let you know that we have another conversation scheduled for the 8th of September. Right, the 8th of September is a little bit of summer break. This can be with another member of the ETH community, Simon Schurle-Finke from ETH Zurich's Responsive Biomedical Systems Lab, and in conversation with Hakan Ceylan from the Max Planck Institute for Intelligent Systems in the Department of Physical Intelligence. We'll be talking about the importance of micro robots, and what they're doing is way cool. Some of this theme about little tiny stuff, right? This is good, but really cool micro robots in the medical world, an exciting and promising field. So please join us then on the 8th of September. And now we're going to hand the microphone back to Katja to tell us what's up next.
Thank you. Thank you so much, Iris and Chris, for sharing an insight of your research. It's very, very interesting and very impressive what you're up to, and we're looking forward to hear more from you. All the best of luck for your future project. Thank you for having you here. Yeah, we will continue with our live audience upstairs on the digital platform. That's another project by the ETH Zurich that we're very happy to showcase here in Stuttgart. So you're all invited upstairs for an apéro. Unfortunately, our online audience cannot join, but I hope to have you back for one of our next events online. Check our homepage. There is more to come, and stay tuned. Thank you so much, and see you soon. Bye-bye.